While getting immersed with force and the laws of motion, let us explore the concept of friction and its effect on motion. Friction occurs because objects have bumps and grooves on their surfaces. Imagine the microscopic view of a very smooth and shiny surface. Even smooth and shiny surfaces have bumps and tiny points on them, which catch and try to stick together when they come in contact with each other. The nature of friction force depends on the type of motion that occurs between two surfaces. If there is no relative motion between two surfaces, friction force that exists between their contact surfaces is called static friction. On the other hand, the type of friction that opposes sliding motion is called kinetic friction. This type is weaker than static friction. The friction force that exists in rolling motion is called rolling friction. This is the weakest frictional force that opposes motion. Friction is less when the weight of the object is less. Friction is also affected by the smoothness or roughness of the surfaces in contact. Rougher surfaces in contact usually offer greater frictional force as compared with smooth surfaces. Sliding or rolling on smooth surfaces is very easy because friction is less. Sliding and rolling on rough surfaces is hard because there is more friction on them. When the surface of one object slides over the surface of another, each body exerts a frictional force on the other. For example, if a book slides across a table, the table exerts a frictional force onto the book and the book exerts a frictional force onto the table. Frictional forces act parallel to surfaces. Frictional force is the force that opposes the motion of an object in contact with a surface, and it acts parallel to the surface the object is in contact with. The magnitude of the frictional force depends on the surface and the magnitude of the normal force. Different surfaces will give rise to different frictional forces, even if the normal force is the same. Frictional force is proportional to the magnitude of the normal force. For every surface we can determine a constant factor, the coefficient of friction, that allows us to calculate what the frictional force would be, if we know the magnitude of the normal force. We know that static friction and kinetic friction have different magnitudes. We have different coefficients for the two types of friction. Mu sub s is the coefficient of static friction. Mu sub k is the coefficient of kinetic friction. A force is not always large enough to make an object move. For example, a small applied force might not be able to move a heavy crate. The frictional force opposing the motion of the crate is equal to the applied force but acting in the opposite direction. This frictional force is called static friction. When we increase the applied force, push harder, the frictional force will also increase until it reaches a maximum value. When the applied force is larger than the maximum force of static friction, the object will move. Before we proceed to solving problems involving uniformly accelerated motion, here's a brief guide to help you translate problems involving motion. For static friction, the force can vary up to some maximum value, after which friction has been overcome, and the object starts to move. So we define a maximum value for the static friction, F sub s maximum, equals mu sub s times n. When the applied force is greater than the maximum static frictional force, the object moves but still experiences friction. This is called kinetic friction. For kinetic friction, the value remains the same regardless of the magnitude of the applied force. The magnitude of the kinetic friction is F sub k equals mu sub k times n. Here is example 1. A box resting on a surface experiences a normal force of magnitude 30 Newton, and the coefficient of static friction between the surface and the box, mu sub s, is 0.34. What is the maximum static frictional force? For the solution, we apply the formula F sub s maximum equals mu sub s times n, and the answer is 10.2 Newton. Example 2. The normal force exerted on a pushchair is 100 Newton. The pushchair's brakes are locked so that the wheels cannot turn. The owner tries to push the pushchair but it doesn't move. The owner pushes harder and harder, until it suddenly starts to move, when the applied force is 3/4 of the normal force. After that, the owner is able to keep it moving with a force that is half of the force at which it started moving. What is the magnitude of the applied force at which it starts moving? What is the coefficient of static friction? What is the coefficient of kinetic friction? For the solution, let's have step 1, maximum static friction. The owner of the pushchair increases the force he is applying, until suddenly the pushchair starts to move. This will be equal to the maximum static friction, which we know is given by F sub s maximum equals mu sub s times n. We are given that the magnitude of the applied force is 3/4 of the normal force magnitude, so F sub s maximum equals 3/4 times n, which is 3/4 times 100 equals 75 Newton. Step 2, coefficient of static friction. We now know both the maximum magnitude of static friction and the magnitude of the normal force, so we can find the coefficient of static friction. F sub s maximum equals mu sub s times n. Therefore, mu sub s equals 0.75. Step 3, coefficient of kinetic friction. The magnitude of the force required to keep the pushchair moving is half of the magnitude of the force required to get it to start moving, so we can determine it from F sub k equals 1/2 times F sub s maximum, which is 1/2 times 75 equals 37.5 Newton. We know the relationship between the magnitude of the kinetic friction, magnitude of the normal force, and coefficient of kinetic friction. We can use it to solve for the coefficient of kinetic friction. F sub k equals mu sub k times n. Therefore, mu sub k equals 0.375. A boy pushes a shopping trolley, weight due to gravity of 150 Newton, with a constant force of 75 Newton. A constant frictional force of 20 Newton is present. A. Draw a free body diagram of all the forces acting on the trolley. B. Determine the resultant force on the trolley. C. Find the coefficient of kinetic friction. Thank you. Any friction or opposition should not interfere with your desire to learn. In studying, stay focused and learn to gracefully resist challenges.